Morse theory or theory of strainless strain. The main point of this theory are: first, all point atoms in cyclopentane and lower member rings are present in the same plane. Second, all atoms in cyclohexane and higher member rings are not present in same plane. That is, they have puckered structure, that is non-planar structure with normal tetrahedral angle. So they have zero angle of strain, and cyclohexane and higher member rings are stable. As cyclohexane are high and higher member rings have zero angle of strain due to their non-polar structure with normal tetrahedral angle, so Sashmore's theory is also called theory of strainless strain. Once bigger rings are formed, they are quite stable due to absence of angle of strain. The bigger rings have no angle of strain, but they are difficult to form due to more distance in between the two ends of the chain. Last, structure of cyclopropane. In cyclopropane, the hybridization of each carbon is sp3 and the expected bond angle should be 109.5 degrees or 109 degree and 28 minutes, but the internal bond angle is 60 degree. So there is considerable deviation from tetrahedral angle of 109 degree 28 minutes, and there occurs large BP bond pair repulsions. To minimize the bond pair repulsions, electron density is somewhat shifted outward on one side of the internuclear axis. So in cyclopropene, the distribution of electron density is not uniform on either side of internuclear axis. This bond is bent outward by some angle called bent angle and giving the appearance of bananas. So the carbon-carbon bond in cyclopropane is called bent or banana bonds. The bent angle is determined by drawing tangent through the old position of bond and new position of carbon-carbon bond in cyclopropane.